Morning, Chethana.
Good morning.
This is
Am
Samson.
Hello, sir. How are you?
Yeah, you're right. Yeah, I'm good. How are you?
I'm good, sir. Thank you.
Okay. So, what news at BIT?
Sir,
What news at your end? Institute?
everything's going well.
Yeah,
So,
okay.
yeah, it's been 2.5 years I finished. So, yeah, it's going well, sir. Yes.
Okay. Good. Hope we also will join for the meeting.
I have informed,
Yes, sir.
sir. Yeah, I have
I too
informed him.
informed that.
Yes, sir. Yeah.
I'm traveling. That's why.
Yeah, I got that. No issues, sir.
Okay. Thank you for accepting our invitation.
No, sir. It's actually an opportunity that you could give me. So, I thank you for that.
Okay. Fine. So, good luck. We'll see.
Thank you, sir. Thank you so much.
I told you to see in the videos. Did you go through the videos? I told you to go back and I told you they show. To take your time. Very hard.
Sir, shall we start?
Yes.
I think we can start.
Yes, sir. Thank you. A very warm good morning to one and all present here. I'm Dr. Sunita Vijayan, Junior Scientist at NATPAC. It gives me immense pleasure to welcome you all to the second talk of TransPedia Research Talk Series organized by KSCSTE, National Transportation Planning and Research Center. This talk series is yet another unique venture of NATPAC designed to explore diverse topics from cutting-edge technologies to sustainable solutions. Here, we will be featuring eminent young researchers to share their valuable insights for kindling the spirit of future research and development in transportation. Today, we have with us Dr. Chethana Ramachandra for sharing her valuable insights on the topic, Decision Support System for Maintenance Management of Indian Highways. Before we begin, I would like to invite Sri V. Sanjay Kumar, Principal Scientist, NATPAC, to deliver the welcome address. Over to you, sir.
Thank you, Dr. Sunita. So, on behalf of NATPAC, I would welcome all the participants, especially Dr. Chethana, to this particular talk series and particular session. As most of you know, NATPAC, since its inception in 1976, has been a pioneer in the field of traffic and transportation in the state of Kerala and spreading its areas across the country. And recently, maybe around 8 months back, we started with the one talk series that is named the TransTech Talk Series, which is delivered by eminent professors on an international acclaim. And since last month, we have started with the new series, that is the TransPedia Talk Series, which is saying that the lectures being delivered by Engg faculties, Engg researchers. Likewise, to start with, we had the faculty, PhD researcher from IIT Bombay, and now we have Chethana Ramachandran. And we have an interesting participants list that is being shown, of course, from across the country. I welcome all of you to this talk series, and a special welcome to Chethana. Nice to meet you, Chethana, and over to you, please.
Thank you, Sanjay, sir. Thank you for the introduction.
Ma'am, a minute. Thank you, sir, for your thank you, sir, for your amiable welcome note. Now, I would like to invite Dr. Remisha TV, Junior Scientist at NATPAC, to introduce the speaker to the audience. Over to you, Remisha.
Dr. Chethana Ramachandra, presently working as an assistant professor in Department of Civil Engineering at B.M.S College of Engineering, Bangalore. She completed PhD from Indian Institute of Technology, Madras in 2021. Her research work was on development of multi-criteria based decision support system for maintenance management of highway projects under the supervision of Professor Veeraraghavan sir, Department of Civil Engineering, IIT Madras. Today, she will be delivering a talk on the topic Decision Support System for Maintenance Management of Indian Highways. On behalf of NATPAC, we welcome you to the session, ma'am.
Thank you, Dr. Thank you, Dr. Remisha, for that meticulous introduction. Now I invite our distinguished scholar to deliver the talk. Please, ma'am.
Thank you, ma'am. Thank you for the welcome. We'll just straight away start off with the talk. So I'm going to be just leading through the research part that I carried out as part of my PhD work at IIT Madras. So with the topic Decision Support System for Maintenance Management of Indian Highways. Are my slides visible?
Yeah.
Yes. So first we'll be dealing with the different stages of the pavement. So when I'm talking about highways, I'm in particularly talking about the flexible pavement here. So clearly we have two types of pavement, one being the flexible pavement and the second being the rigid pavement or the concrete roads. So I'll clearly be focusing only on the flexible pavement today. So the first part is where the pavements are newly constructed. So that's the first stage of any pavement. And over years, what we can see on the right side is how the pavement undergoes failure, different kinds of distresses that it undergoes, maybe after a period of 10 years, 15 years, or even lesser, based on what the climatic condition is and the traffic is. So coming to that, I am just showing two scenarios. So India, where we have heterogeneous traffic conditions in our country, so most of the highways are loaded mostly by the trucks, 2-axle, 3-axle, multi-axle trucks. Some of the highways might not be loaded. So that is the criteria that we need to be considering as well. The second figure here on the slide shows where we are dealing with different kind of climatic conditions. So if we talk about the nature of the country, so starting from, if we say, let's say Rajasthan or Gujarat, where we have as high temperatures as 48, 50 or 51 in the summers, we are talking about temperatures which can go to sub-zero in the northern side of the country. So what do we actually design the pavement for? Or how do we talk about the maintenance as part of the design is what we'll be going through. So I think this is something which most of the pavement engineers who would have talked about maintenance or design would be familiar with this figure, where we are talking about the time. The time is from the initial construction of the pavement to how it deteriorates over time. That's the age of the pavement. And then on the y-axis, we have the pavement condition, where we are talking about the condition of the pavement, or what we can call as serviceability of the pavement. Right. So when we say serviceability, so since the pavement is an infrastructure, we are expected to behave in a certain manner or be serviceable to the users who are using the pavement. Right. So right from the excellent condition to the failed condition, where I showed in the second slide, where we saw a failed condition could be the last part of the pavement or the end of the pavement where it undergoes a rehabilitation. Right. So on the y-axis where we have the pavement condition, so how do I decide as to where do I do the pavement maintenance? So do I do it at the, let's say, the second year, the 5th year, 10th year, 15th year? How do I take this decision as to when I'll be doing the maintenance is also part of what we'll be talking about today. So again, we could be dealing about with different kind of maintenance strategies. So we are not talking about a single material or a single kind of mix or a mixture, bituminous mixture, or any other type of material that we could be using. So we could be having a wide variety of materials that could also be chosen for the maintenance. So the focus for the highway agencies these days is mainly to maybe maintain the existing pavements rather than constructing the new ones, right? So we have a long length of highways across the country, the national highways, the state highways, etc. So the focus is on how to maintain them as well, apart from constructing or connecting different parts of the country. So we have different types of projects. Currently, the scenario in India is where the maintenance is schedule based. So now what do I mean by schedule based? So if you take in the urban scenario or even in the national highways, so there is an overlay provided to the pavement. Overlay when I say bituminous concrete or any other type of stone mastic asphalt, etc. So for the second year, 4th, 6th, 8th, etc., whether the pavement has deteriorated or not deteriorated, the maintenance strategies are carried out. So is that feasible economically? I would like to differ there, because we say that once the pavement has deteriorated or we know that it's on the verge of deterioration, then it would be wiser to carry out a maintenance strategy. So that is what we call it as the performance based versus the schedule based. So currently what we follow in the country is schedule based. So next, coming to the life cycle cost analysis, all that we consider at the initial construction of the pavement during the initial construction is where we are talking about only the maintenance, the design cost or the material cost, etc. So none of the agencies bother about what is the cost that incurs because of the maintenance that has to be carried out over a period of years. Or if we consider a flexible payment has 15 years. Neither does it talk about the benefits that are going to incur to the agency, nor the benefits to the road user. So all these need to be carried out when a new pavement has to be started for construction. So with that, in the slides to come, I'll be talking or emphasizing more on a term called system. So what do we have as this system? So we are talking about the pavement management system, where it is a set of tools or methods that aids the decision maker. When I say the decision maker here, we are talking about the agencies which take the construction in finding ideal strategies when we mean the different kinds of maintenance strategies for providing and maintaining pavements at or above the desired serviceability. So as per the AASHTO, if we talk about, there is a certain criteria of serviceability supposed to be maintained or met when a pavement is constructed. So over a span of time, which we in our terms we call as the design life, right? So with that, we came up with the PhD's research topic, where we thought about the different criteria that is going to be affecting the pavement. So we will develop a framework where each of the agencies who take up the projects, the flexible pavement construction, should go through a certain kind of procedure or let's say a methodology which they should follow during the course of time, during the construction towards the up till the rehabilitation, and how they can improve the performance of the pavement accordingly. So we'll be talking about structural performance, functional performance. We'll deal with it a little in detail in the slides to come. So the research question here is where we are developing a multi-criteria based decision support system for the maintenance of the bitumen highway project. So that's what we are talking about. So we have certain research objectives which were fulfilled as a part of this work. So first is we'll talk about the performance prediction models. So we said we have to know what is the performance. Performance, how do we measure them? Maybe in terms of the rutting that's going to occur, in terms of the cracking that's going to occur, in terms of deflection measured either through Benkel beam deflection meter, which is kind of getting outdated. So we use the falling weight deflectometer. So we measure the distress parameters and try to project it or predict it for the entire design life. So that's the first part of it. Next, we develop a framework to decide the timing. So I mentioned that we have different kinds of maintenance strategies. So what is the right time where we are going to maintain with different traffic levels? Of course, we talked about traffic levels because it's not uniform throughout the country. So we are talking about different traffic levels as well. And next is to consider at what point should I maintain. So I talked about the performance based versus the schedule based. So we'll talk about two terms called as the trigger level and the threshold levels, where we are talking about what is it that is going to trigger the maintenance. How do I decide when I'll perform the maintenance? Next is, once I do a maintenance strategy, how can I quantify the effect of the service life? Is the design life going to extend? The design life is for 15 years. Can I extend it when I do this kind of a maintenance strategy? We'll also be talking about it on the economic aspect as well. So last is I'm going to give a framework considering all of the above parameters. So this is the methodology. The flowchart depicts the methodology. So when we talk about payment management, we have two levels. So one is the network level where I'm considering the whole state. Maybe like I consider the whole state of Kerala. I can decide what is it going to be into Trivandrum, Cochin to Alappuzha, etc. So I can consider all the roads on the contrary where I am talking about the project level. I'm only talking about one stretch of road. So one stretch of road connecting point A and point B. So I'm going to deal in depth about the different kinds of maintenance strategies or the materials design, etc., only for that particular road. So what we are working here is only at the project level. So next, we go to the performance prediction models, which I just spoke about, where we determine the different kinds of distresses. So from the performance prediction models, I have different sub topics here, where we are talking about the structural and functional aspect. As we understand, when I say structural, so it is the entire layer or different layers of the pavement which is actually considered. Functional refers to only the top layer of the pavement, which is involved in the maybe the safe movement or the comfortable movement to the road user. So we have different traffic levels, then we have the different structural and condition. So the threshold levels is what I just mentioned, where we'll be talking about it. And then we have different maintenance interventions. So the cost of using a particular intervention, the different kinds of strategies that we are going to be using. Again, when I decide what will be the performance prediction, I am going to adopt two kinds of maintenances. One could be a preventive, one could be a corrective. And what are the cost implications of choosing either preventive or corrective? And finally, I'm going to come up with a set of optimal maintenance treatments. So how am I going to model the whole thing into a single system? So I said system is something which we'll be using very frequently. So pavement does not behave as a single, it is not a single material, or it is not a single component. There are multiple components which are involved in the proper functioning of the pavement. So that's where we have modeled all of the parameters which we felt were influencing the performance of the pavement using system dynamics. So we will talk about the first objective. So first one is where we decided to have some performance prediction models. So there are four kinds of models that we looked at. Some of them were actually taken from the data or from the data that we actually used for modeling, which was one of the measure deflection areas in the state of Karnataka. So we have taken the actual data and we have done the modeling part. So first we are talking about the deflection prediction model, where we estimate the deflection in millimeter based on the initial level of deflection. So initial level of deflection is when the pavement is constructed, it would be at a particular deflection. So based on that, how is the deflection going to be over a period of time? So that's the deflection prediction model. Next, we have the rutting prediction model. Rutting, as we know, is the depression, or let's say some deformation in the wheel path of the highway. So we are measuring the rutting prediction model, or we are determining what the rutting is going to be. The cracking in terms of percentage. So the area of cracking, from that we'll be able to determine the percentage of cracking. And the last is the roughness prediction model, which is measured in terms of IRI by meter per kilometer. So in the current scenario for our Indian condition, so we have rutting and cracking. So these are the two main parameters which we will be using as part of our IRC 37 2018. So where we consider some amount of rutting, like let's say 20 mm, and 20% of cracking as the threshold of up to which, or the last point up till which we can the pavement can be serviceable. Right? So, but we do not consider other parameters like roughness, deflection, or even in terms of patching, potholes, we do not consider all of that. What we realized is that the rutting, cracking, and roughness is a function of deflection. When I mean function, so it is directly dependent on the deflection of the pavement. So with that, we realize that deflection prediction model, or the parameter deflection, is the main parameter which needs to be considered irrespective of what kind of distress we are looking at. So since everything is dependent on deflection, so rutting, cracking, roughness, or even patching, graveling, whatever distress we would want to measure is dependent on a parameter called a deflection, which becomes the main criteria for our work. So once we determine the performance prediction models, this model could either be a linear model, non-linear model based on the different data that we have collected and different parameters that we are going to consider. So this data was validated using another highways data, which more or less look like a similar highway. So that was done. And then the initial structural condition of the pavement, traffic level, and the timing of maintenance, these were found to be the significant factors influencing the performance. So when we say significant or the influencing parameters, most of the performance prediction were dependent on these three variables. Hence, they form a major role in deciding what treatment strategies that we are going to adopt later in the work. With that, we come to the second objective, where we have the development of a framework to decide the optimal timing. So we'll be talking about different kinds of treatments and the cost. So we have adopted 4 traffic levels. So as we know, the 2000 IRC 2012 had an MSA up till almost like 150 MSA. But if we talk about the 2018, the code gives us only traffic levels or MSA up to 150, right? After that, it's our decision or the design engineer's decision as to how the pavement is going to be constructed with a high traffic, right? So 75 is considered as a minimum traffic, considering that we are talking about the national highways, and the maximum being the 150 MSA. So 4 levels of traffic have been chosen, considering that 75 is a low volume of traffic and 150 is a high volume of traffic. So we have also considered the design period of 15 years for our payments, so to predict the performance. So the procedure for prediction after we develop the distress models is very similar to what we have in the IRC code. So after that, we are talking about structural adequacy with the initial deflection levels. I mentioned in the slide where we have developed the performance prediction model that the structural adequacy or the initial deflection level for the pavement formed a very major influencing parameter to decide the performance. Hence, we have kept that as the criteria to decide the framework. So 0.25 mm, 0.35 and 0.45 mm, that we have considered as the value where we can predict the future performance of the pavement if pavement initially has 0.25, 0.35 and 0.45. Again, how have I come up with these values 0.325, 35, 45? This is not something which we randomly chose. A questionnaire was circulated throughout the to most of the professionals around the in the country, so or the practitioners in the field of pavement engineering. We asked them to we had a set of questions where we asked them what is the level of deflection that is acceptable. So these values we got from the questionnaire or from the answers to the questionnaires where we have decided these parameters. So next we'll be talking about the choice. So we said we have now different traffic levels, then we have different initial deflection levels. Next is where we have the choice of the treatments. So we mentioned that the choice of the treatments could be varied. So with the advent of materials or with the research going on in materials, so there is a provision to adopt a wide variety of materials. So even if I just take a simple bituminous mix, let's say for example, bituminous concrete, I have different aggregate size or the nominal maximum aggregate size which I could be using for the surface layer. Again, the bitumen that I'm using could be very different. So now I'm choosing the routine maintenance. So what do I mean by routine maintenance? Routine maintenance is something which is carried out on a general basis, irrespective of the performance of the pavement. So that could be as simple as removing the loose particles from the road, patching the potholes, or maybe sealing the cracks. Very minute or minor repairs like that come under the routine maintenance. So they do not form a major chunk of the whole cost of the pavement. So next is the preventive maintenance or the minor rehabilitation. So when I say preventive maintenance is even before the pavement fails, that is when it is structurally sound. When I say structurally sound again, the deflection is very less. So even before it starts to deteriorate, I'm going to provide a certain kind of preventive maintenance. As for the minor rehabilitation goes, I'm talking about thickness of bituminous courses like maybe 30, 40 or 50 mm of the pavement. So major rehabilitation is where we are talking about thicker maintenance strategies, like where we have bituminous concrete and dense bituminous macadam, or bituminous concrete up to 75 mm thickness, maybe in 2 layers, so etc. So first we'll see the preventive maintenance where we have varied options. So we could have a fork seal, slurry seal, micro surfacing, surface dressing. Again, in surface dressing, we have the single coat or the 2 coat based on maybe the kind of material availability or what kind of the pavement, the functional deterioration. We can choose the preventive maintenance. What we need to remember here is preventive maintenance is only applicable when the pavement is structurally sound. We can't go for the preventive maintenance when the pavement has started to deteriorate. So I was just mentioning about the choice of bituminous layers as well. So bituminous macadam not generally used in recent years, but then we have dense bituminous macadam, SDBC, BC. Even when I choose BC, maybe let's say the grade 1 or grade 2 BC or grade 1 or grade 2 DBM. Again, I'm not sure which kind of binder I could be using. Again, if I choose the binder, should I use a modifier? Should I use an elastomer? Should I use a plastomer? Crumbed rubber modified bitumen is something which is being explored. And in the recent past, we have even plastic and shredded glass which could be used in the binder. So we have a wide variety of options. And if we talk about the thin layers, we have the pre-mixed carpet or the mixed seal surfacing or the seal coats. So I have a wide range of materials or mixes that I could be using. So apart from that, when we talk about the major rehabilitation, also I have a different material that could be used. So if I talk about the bituminous mixture, am I going to use something which is recycled or which is, let's say, the warm mixes that which is gaining importance very recently. So we have the warm mixes or the recycled wrap, what we call as. Again, if we do the recycling, the decision lies whether we do a in situ, that is in the field, or do we do a plant recycling and go back to the field. There are a wide variety of options that are available. So we need to explore based on the availability or the economic aspect, what is it that is going to fit in the project that is taken up. So all of it is not possible, or maybe one of it might be wrong. So need to explore as to what would be the feasible solution. So here we are talking about a new term called as the trigger point, where I say, let's say this is the performance of the pavement. So we see a deteriorating pavement here where the condition is deteriorating over the period of age. So if I provide a treatment one, let's say bituminous concrete, so then this is how the pavement would perform. On the contrary, let's say if I use stone mastic asphalt, so there might be an increase, a higher increase. So where it's required for me to do or provide 2 layers of bituminous concrete, all I need to provide is 1 layer of stone mastic asphalt, which is going to be effective compared to the two provisions, 2 times provision of the bituminous concrete. So when we say 2 times provision of bituminous concrete, the cost is also going to vary. So here the cost is only once and the performance is also higher when compared to the bituminous concrete. So the choice of the treatment is something that we need to be very sure of. So next we were talking about the pavement as a system. So we talked about the traffic initial levels or the material itself, right? So how do we actually consider this as a system and how do we model it is something which we have done using the system dynamics tool called PowerSim. So this tool helps us actually model the whole behavior of the pavement or the different components or the influencing factors of the pavement modules into a single system. So we have developed different modules like this. So one is where we have the traffic module. So here what you can see is the structural module, the functional distress module, where all we are talking about is the initial deflection and how that's related to the progression of roughness. Then we have the structural distress module, where we have different strategies that we are going to consider. So I have the, let's say, the initial deflection. If I perform a particular kind of treatment, how is the performance going to be is what I'm going to model. I have shown each of these as different parameters or modules here, but they're all interconnected to form a whole single module, which we are talking about as the system. So we also have the structural distress module, and then we have the cost module here, where we are talking about cost of different kinds of treatments, or maybe the preventive maintenance, corrective maintenance, etc. And then what is going to be the cost at the end of 15 years? Though how much ever we say that it is important for the payment to behave in a particular manner, in a developing country like ours, it becomes important that we also look at the economic parameter. So this is where we can, the implication of cost comes into picture. And then we also have a traffic module. So all of these modules, the cost, the distress modules, etc., is dependent on the traffic module, because there is no deterioration of the payment without the traffic. So that is something which we need to rightly project. With this, so now we saw that there are different traffic levels, there are different kind of distresses. So when do I know that I have to perform a treatment? So that's something which we call as the threshold level. So we consider 3 threshold levels of performance as is currently practiced in India. So with the effect of the threshold level, so when we say threshold level, so one, we spoke about the trigger point, where I say when the pavement deflection reaches a certain point, I'm going to perform a maintenance. So when I say the threshold level, it is something beyond which it should not fall. So if I say the condition should not fall, so threshold, when I say roughness, so initially we have a roughness of, let's say, 2.5 meter per kilometer. So over a period of time, let's say at the 10th year, it should not reach so much. So that is what I call as the threshold level, or we can also call it as some acceptable level, or the threshold level as what we are calling it here. So beyond which the deflection should not increase, beyond which the rutting should not increase. So what is it, that value? So again, I'm not considering for every distress separately, because we need to look at a kind of many distresses put together and not look at a single distress, right? So, and what is the benefit that's going to occur when we adopt the threshold level differently? So now if I do a maintenance at 2.5 meter per kilometer roughness, and if I do a maintenance at 3.5 meter per kilometer, what is the benefit that is going to be incurring to the agency? So we'll be talking about the benefit area in a while. But before that, we have adopted 3 threshold levels. So for roughness and deflection, as one depicting the functional parameter and one deflection depicting the structural parameter. Again, why only deflection? Why not rutting or cracking? Because I already mentioned that rutting and cracking is a function of deflection. So though I project it separately or in a different as a different parameters, it is again correlated to deflection. Hence, we have taken deflection as one parameter. So when I say threshold level 1, I'll provide a preventive maintenance. If the roughness increases, or as soon as it reaches 3 meter per kilometer, I'm going to provide a preventive maintenance. Or the deflection should, we are not going to, why is the deflection less than 1 here? Because when we do a preventive maintenance, I emphasize that the pavement should be structurally sound. So we are not talking about deflection in the preventive maintenance. For a minor rehabilitation, so as soon as the deflection reaches 1 mm, I am going to perform a minor rehabilitation. Minor rehabilitation when I have a bituminous concrete or DBM, etc., which I have less than 50 mm in thickness. So major rehabilitation, when the pavement becomes very rough, around 6 meter per kilometer, or the deflection is 1.25 mm, I'm going to perform a major rehabilitation. Likewise, I have defined different values of threshold 1, threshold 2, and 3, where we are going to perform. So what is the benefit area that we are talking about? So one, we have the minor rehabilitation, which the point at which it triggers a performance or maintenance is the trigger point, and then the level beyond which it should not be increasing is what we have defined as the threshold level. So we have the minor rehabilitation, the threshold level, and the major rehabilitation, a typical performance. So what do we understand now by the benefit? So one, we mentioned this is the first deterioration of the payment. I perform, this is the threshold level beyond which it should not be moving down. So I give a maintenance strategy, and then the performance increases. Again, after the material starts to degrade, it's going to deform again. Again, there is going to be a deterioration in the pavement, right? So the area below this performance curve is what we call as the benefit or the benefit area. So this is for one kind of strategy. So now if I consider a preventive maintenance, so I said preventive maintenance is when the pavement is structurally sound. So even before it starts deteriorating, I'm going to provide a treatment. The area under this preventive maintenance or rehabilitation is what we define as the benefit. So this is something which is for the entire condition of the pavement. What we here have is given for roughness. So again, I've just shown typical graphs here where we have the roughness is continuously increasing for the design life of the pavement. But at a particular year or when the threshold is reached, if I provide a maintenance strategy, the value of roughness comes down, it increases, comes down, and again increases. So the benefit area is the area between where we have this no performance, no maintenance strategy carried out, and the curve where we have a strategy carried out. The difference or the area in between these two performance curve is what we call as the benefit area. And this benefit area is computed for different traffic levels and different levels of initial deflection. Then there was a comparison done between the three levels of thresholds, which we just spoke about, and the benefit area for each of that was considered. So what did we understand from the implication of the different threshold levels was that, so the pavements always perform better when the deflection is less or the initial deflection is less, right? So how do we ensure that the initial deflection level is less? So one, generally the pavements do not have high roughness and deflection at the initial stage, but maybe with the right kind of construction practice or the quality control of the materials at the site, so the initial deflection can be very well ensured that it can be maintained at a lower level. So the threshold level 2 or 3 is where we saw the highest benefits in. And the next important parameter that we observed was the preventive maintenance. The timing for the preventive maintenance is when the roughness reaches 2.5. So corrective maintenance, we had a certain value. So what we decided as part of the threshold level, so the benefit also we were getting accordingly. So that is something which was observed. And again, how did we decide? So these are some values which we got from the schedule of rates, so which is available in different states. So we just took the values for pothole repair or BC overlay of 30 mm for the different condition, for the different, under different parameters, different heads. And then we determine the cost per 2-lane kilometer, and we use that for the computation of the benefit cost. So now I need a parameter which actually decides what strategy is helpful. So I quantify that maybe with different, there are different yardsticks by which I can do the economic analysis, benefit cost ratio, NPV or the IRR, etc. So here we have just used the benefit cost ratio. So where we have, I'm just shown a sample calculation. So I have the benefit area of certain value, then I have the ADT, the traffic, and the cost. So I determine what is going to be the benefit cost ratio given a certain scenario. So this way we have computed for all the cost for our this thing. I'll just show that in a while. So this is a summarized table which shows where I have different traffic levels that we have adopted, different initial deflection levels, which we say was a very important parameter. What you see here as 1, 2, 3 refer to the routine maintenance, which is 1, 2 refers to the preventive maintenance or minor rehabilitation, and 3 refers to the major rehabilitation. So if I take 75 MSA and 0.35 mm deflection, initial deflection level, so I'm going to do a routine maintenance every year. So this is irrespective of any other maintenance carried out. So this is going to be there. In the 7th year, when the threshold level changes or increases, so I provide a preventive maintenance. So again, it is good to go for other 4 years before I can carry out a major rehabilitation. So this is because the initial level of deflection is high. So if I look on the contrary for 0.25 mm deflection, so instead of just sustaining for 4 years, I can sustain up to the end of the design life. So this is the kind of impact that the initial deflection has on the performance of the pavement, which needs to be very carefully looked at. So based on the benefit area and the cost incurred because of the routine maintenance, preventive and the corrective maintenance, the cost was calculated, and then hence we determine what's the benefit cost ratio. And we very well know that higher the benefit cost ratio, higher it is beneficial to the agency. So the next objective we'll be looking at is where we are talking about whether the life of the pavement is going to be extended if we use a particular treatment, right? So we have considered deflection as the main criteria here. So if I now provide, so that we have a deflection of, let's say we have 75 MSA and 0.35 mm as the initial deflection. If I provide a treatment here, a preventive maintenance, that is the blue one, and then we have a corrective treatment. So then definitely the deflection drops down and then it increases. So instead of failing at maybe the 11th year, the pavement is going to sustain for other 5 years and it's going to be there or till the end or be serviceable till the end of the design life. So by this, we mean that there is an extension of the service life for another 5 years instead of failing at the 11th year. Similarly, we have for the 75 MSE and 0.45 mm deflection, where again, instead of failing at the 6th year itself, because we have the initial deflection quite high, so it's going to be extended for up to like say 10 years, where it's going to fail in the 6th years up till like almost 15 years, it's going to sustain. So when we mean that, so we have for different traffic levels and the initial deflection. So we see that as the initial deflection increases, the number of treatments also increases as well as the cost increases. So that's something which needs to be taken care of. So here we've shown where I have plotted where we have the acceptable service level, or what I also called as the threshold level. So the red one is where we have the high initial deflection. Then we have the little green color one for the medium deflection level and the blue one for even less. So the blue one, as you can observe, is rarely coming down up till the acceptable level. So it is not going down beyond the acceptable level, which suggests that the initial deflection needs to be very less if we need a better kind of pavement, right? So again, PM, so where we are talking about the preventive maintenance, and here we are talking about the corrective maintenance. So we just summarize the whole thing where we have the different traffic levels. As you can see, we have 75 MSA, 100 MSA, and then we have 125 and 150. We have considered for all of these traffic levels, different threshold levels of 1, 2, and 3, and the initial deflection parameters. And we have tried to determine what's going to be the highest benefit cost ratio, which is going to be beneficial or help the agency economically. So the highway agencies, what we are talking about, are different agencies. So one is they need to be briefed up, or they need to be sure of what is the threshold level that needs to be carried out. So we have talked about different structural adequacies, etc., with different kinds of treatments. So we saw that, so these are the likely suggested threshold levels for different kinds of traffic levels and the initial deflection levels. I think mostly threshold 3 is the one which is used across, or which is feasible, or I would say optimally feasible across the different kinds of traffic levels. So I would just like to summarize in the next 2 slides. So we have spoken about pavement as a system. Generally what is done is we do the pavement design, but we do not consider the maintenance aspect at all. We do not decide what is the performance, or what is it that's going to be the cost of the performance, etc. So we only do the design, we get the different thicknesses of the pavement, we check for the rutting criteria to be satisfied, we check for the cracking criteria to be satisfied, and then that's it. So what we need to look at is all the different agencies which deal with pavement engineering, or maybe the how we should be practicing is that we should deal with it as a system rather than as an individual component. So the payment is encompassed by variety of components that as we have understood. So next is the cost. One is the road user cost. At no point of time do we evaluate what is the road user cost. All that we have been evaluating is the road agency, the agency cost, that is what is the concessionaire going to be benefiting, or how much is the cost that is incurred to the concessionaire, etc. At no point of time is the user considered. So that's something which needs to be looked at. We have road user cost studies done decades ago, but with the kind of different kinds of vehicles, the electric vehicles, or when we are using alternate modes, alternate types of fuel, right? So what would be the cost implication across different kinds of usage of fuel, etc., is something we can look upon. And then the timing is very important. So the year of maintenance, or the point where it needs a maintenance or a strategy to be used on the pavement, is something which we'll be looking at. So we'll just list it down. So what could be the possible framework that all of us could be using across the country? And since NATPAC is something which you deal with at a national level, so I'm putting this across in this forum because one thing where we are talking about different kinds of distresses, we should be kind of looking at a similar format of collection of data throughout the country. So if we take an example of US, so they have decades and decades of data available for the modeling aspect. And also I'm not saying that the roads there are very good, but when we compare few of the criteria, or maybe the methodology adopted, maybe that is something which we can adopt as well. So normalized across the country, maybe the equipments that we are using to collect the distress, or the data sheet can be uniform. We can come up with a code where we say this is the parameters for data collection that we need to look across. And then we have the prediction models. So this becomes site specific. I have designed the model for state of Karnataka. I can't use the same thing in Kerala or maybe another region. So that's something which needs a little thought about. And what are the main influencing parameters is what we need to correctly identify. Then the decision of the right maintenance treatments, where we have a large variety of materials. Then the timing. And after all of this is done, so we need to again start evaluating the pavement. So our work does not stop at collecting the data, predicting the performance, or giving a certain maintenance strategy over a period of years. For example, even the deflection data that I had, which was there. So we had around 3 to 4 years of data of deflection, which we could use. So unless there is some periodical evaluation of the pavements, I don't think a comprehensive model could be developed. So maybe if we consider these parameters in order, there could be a good decision support system for the pavement. With that, I would like to conclude my talk. I would like to acknowledge my supervisor and guide, Professor A. Veeraraghavan, who has been a constant source of support and guidance throughout my work and even after that. And then for NATPAC, the chairman and director for coming up with this thought of giving a platform for the young researchers like us to explore. So which also gives us more confidence or something where we can know what the other people across the country or globally are doing as well. So thank you for that. Shalini ma'am, I very grateful to her because there were different conversations that we had, and she instantly asked if I would want to give a talk, and that's when this whole process materialized. And Mr. Ashik Azar, so I think he's been in constant touch since we decided that I'll be giving a talk here till today, where he has been keeping in touch, giving me reminders and etc. So thank you for that. And B.M.S College of Engineering, which I'm currently a part of, and everyone who has been a part of the research journey. Thank you so much. So if there are any questions, I would be glad to answer those.
Thank you, ma'am. That was really an enlightening talk. Now the forum is open for discussion.
Good morning, Dr. Chethana.
Good morning, Sanjay sir.
Yeah, I have a question. You had
Yes.
mentioned about the deflection values in the initial slides, like you had benchmarked three deflection values were there. So
Yes.
that deflection values was corresponding to which layer actually?
Deflection, we are talking about the top layer.
So you had considered only the deflection of the top layers for evaluating this theory, right?
Yes, yes.
So, why the lower layer, the deflection values of the lower layers was not considered, or?
So one, if we consider rutting, for example, rutting could be a function of let's say, the insufficient compaction of the bituminous mixture or some failure in the subgrade, right? So there could be different aspects that we are talking about, different layers when we are talking about rutting. But if we talk about cracking, again, there are two types of cracking where we talk about the top-down cracking or the bottom-up cracking, right? So this data that we had, why I'm saying that it is a function of the top layer is deflection data was collected using the Benkelman beam deflection meter, right? So where now we talk about the falling weight deflectometer, we can back calculate, or we will be able to determine the deflection of the different layers starting from the top layer to the up to the base layer. We can determine the deflections. So this, since the data which we had used was for the Benkelman beam deflection, it is not a characteristic of the lower layers. So hence a reason that I have taken. And what I am mentioning here is just a framework. So if we have elaborate or extensive data available for deflection or even other kind of distress parameters, any agency can very well go with it, and that would give a more accurate prediction model rather than just considering the top layer of deflection.
Okay, thank you.
Yeah.
Hi, Dr. Chethana. I'm Shalini here.
Yes, ma'am.
Thank you, Chethana, for a very enlightening presentation. And I would like to ask you about the incorporation of the drainage characteristics or the climatic and environmental factors in the system dynamic approach, whether it was been included in, or because as regard to Kerala, the factors like absence of rains and the climatic factors is going to be a very aggravating factor in the decision of the routine or periodic maintenance, whatever it be. So
Yes.
I would like to just know about how these elements could be incorporated in this approach, or any thoughts upon that which you can invent.
Yes, ma'am, sure. Yeah, I agree because Kerala has high rains. So routine maintenance is something which needs to be very carefully looked at, or even preventive maintenance. So what I could do is probably in the distress module. So I have not considered climatic aspect here, or maybe it is indirectly considered where I choose the kind of uh, binder that I actually adopt, right? Some of the binders that I use are which can withstand or extremes of temperature. Some are used where the viscosity is less, is for a particular kind of climate. So if I can either adopt the different kind of binder where it is more hydrophilic, right? So that is one aspect where I can incorporate the material parameter, or on the otherwise, I can also consider a separate module for cracking where I can predict the cracking or the rutting, any kind of distress based on the temperature. So that is, again, I need some periodic or historic data which needs to be made available. Else I'll not be able to just predict what the performance is. So maybe now before rains, if we can know what is the kind of performance that Kerala roads have. And then after rains, if we have an evaluation of it, the comparison probably would give an idea of choosing what kind of binder will give me what kind. Again, temperature also can likewise be adopted in the module. So again, when I say system dynamics, it's not necessary that I use a very sophisticated tool for it. I can use a simple spreadsheet and also try to determine the performance. So it's not necessarily that we need to have a lot of kind of modules and make it look this way. So as simple as a spreadsheet could do enough. If we identify the parameters enough and we have sufficient data for the evaluation, I think that should serve the purpose of taking care of the climate and the temperature aspect as well now.
Thank you. Thank you, Chethana.
Yeah, thank you, ma'am.
Chethana, there is some one question in the chat box. That is
Yeah.
the decision support system. What is the DSS that was made, and what its availability, whether it's a standalone or an online?
I didn't get the question. Sorry.
The question is like, can you share some light on the DSS that was developed? Is it available online or is it a standalone system? It's by
No, it is, we are just giving an idea saying that this is what the practitioners, the agencies, the researchers could do as a framework. So it's not available online. Another paper related to this of mine might be available, but this whole DSS as such is not available. But this is something which we just did for one, I could call it a case study. So it is going to vary from place to place, material to material, etc. This is just the skeleton or the framework that I have given, which they need to fill in their material data and then come up with their own kind of decision support system.
Any other questions from those who are online? We have a lot of experts in the domain. Of course, Professor Vedam sir is definitely there. And apart from that, Dr. Ujjal, Dr. Priya, and from CET, Dr. Nidhu Roy. So anybody would like to share some comments or something? Yeah, definitely, Chethana. That was an enlightening session, especially Vedam sir yesterday also had shared me one video specifically from Kerala context wherein this drainage was an issue, and which Shalini also was mentioning about Kerala. Of course, this drainage is the basic issue that we are seeing.
No, but I think even that is what I keep thinking and telling sir also, even the kind of roads that we have in Bangalore, for being a cosmopolitan or soon to be a metropolitan city, I think we are lacking in the kind of works, but now mostly many of the roads are being white topped and we have the concrete on top of it. But I don't know if that might be the answer to already existing roads. So I don't, maybe we should give a little more thought about maintenance of roads rather than just having a long length and breadth of the roads. So that's what my thought is. Yes.
So doing the right thing at the right time with the right
Yes.
material.
Yes.
Sanjay, I have to discuss with the Professor Veered. Thank you, Professor, for joining. And this one to the guide as well as to the student, knowing the situations of Kerala, road network, climatic conditions, terrain, then the traffic. Can you suggest what should be the strategy which we should adopt so that to maintain or keep our road network in a reasonable good condition?
So do you want to?
Maybe, sir? I think he's not there. Maybe. I think he is not there now. Chethana, you can give
Yes.
an idea.
Yes.
Please.
Yeah, so what I specifically here have given a framework is for the project level. But yeah, sirs, another student has worked on the network level. So the decision that we take at the project level and the network level is very varied. It's very different. And here, when I go in depth as to what is the material, what is the kind of binder, bituminous mixture that I'm going to use. When you're talking about the whole state of Kerala, maybe, so it's more about how do I prioritize the different sections of roads or different roads rather than choosing what I do for each of the roads. So it's like I want the whole state of Kerala to have good roads. So I am more looking at do some strategy, but keep the roads in a good condition. I'm not bothered more about what is the exact kind of strategy I'll be looking at. It is rather more if I do this at this stage, so it is going to be in a good condition. That's what matters when we talk about a network of roads. So if maybe that's again something which is very subjective. Each of the researchers have their own view on what is the best kind of material available, though maybe the evidence might be showing otherwise. So it is again the economic aspect also which comes into picture. So maybe if we talk about one kind of mixture, like what we have as the expert system or anything, at least if we have a record of, let's say I use a certain strategy in such and such a condition where the climate is so, temperature is so, if I document it and make it available online, right? So I can use it as an expert box where I can retrieve the data and try to use the same strategy if my temperature and climate is something similar to what was already done. So I think this is my idea because where I can have a whole data toolbox, I can just keep retrieving what I need. But I think maybe we should start taking the initiation to have this documentation be it available online. So for example, one of the questions asked was, is it available online? It's not, because it is very subjective and it is restricted only to a particular area. So I think if we are able to have that whole system where we can just input the data and maybe get a guidance from the system itself and then use it for our work. I am not sure how much of your question was answered, but these are my thoughts on that.
Okay, thank you, Chethana. Now, maybe to supplement that, probably, can you suggest what should be the bare minimum data to be collected and the frequency? Because we have a big network.
Yes, yes,
Research,
yes. That is,
and yeah. So even
this is
NSTD, you
exactly,
know,
yes, sir. This is exactly
so
why
in
I
that,
wanted to put across in this forum, because NATPAC has connections, or your network is in CRRI, NHAI, and all of those bodies as well. And researchers from throughout the country, you get to meet them. So even at least if we have the roughness data, the deflection data, and what kind of maintenance is done at what year of the design life, I think that would be more than enough to start off with. So once we get the hang of when to do the maintenance, or it is established as a code itself, then probably we can start exploring more volume of data as well, I think, sir.
okay, thank you, Chethana. You know,
Thank you so
Priya
much,
is
sir.
also there. Priya, you would like to add something? Priya or Neetu? Okay. And out to Sanjay.
Now I invite Sri Shrijit Preeti, Junior Scientist NATPAC, to propose the vote of thanks.
On behalf of NATPAC, I would like to express my sincere gratitude for each one of you for joining our second TransPedia Research Talk series on the topic Decision Support System for the Maintenance Management of Indian Highways. It has been an interesting and outstanding session. First and foremost, I would like to express my deepest appreciation to our distinguished speaker, Dr. Chethana Ramachandra, for sharing your valuable research finding with us. Thank you, Dr. Chethana.
Thank you,
And
sir.
this is like we all know that roads are the pioneer for the development of any nations. But in Indian highways, as we see in the traditional way, like for some particular traffic, according to the chart, we design for the payments. But overall, we know that the traffic, the climatic conditions, and the soil support system, the subgrade quality, it matters. It differs from each states, and the performance, like at each state, the maintenance strategy required is different. So your performance-based model, your research, that is extremely good for the upcoming maintenance strategies of the nations. And I would like to express my sincere thanks to all the attendees for your participations and thoughtful questions. And we believe that our TransPedia Research Talk series is getting beneficial to our students, researchers, academicians, and working professionals, etc. And our heartfelt thanks to Dr. Professor Veeragavan sir and faculties experts from different organizations across the country. Furthermore, a big thanks to our director, division heads, and each coordinators for making this event successful. Your support has made it possible for the come together and explore this important topic. And in closing, let us take a lesson and ideas discussed today and apply them to enhance the maintenance management of Indian highways. Together, we can contribute to safer, more efficient, and well-maintained road network for the nations. Once again, thank you. Thank you all.
Thank you, Chethana. Thank you,
Thank you,
Professor
sir.
Veeravan.
Thank you, sir.
Thank you.
Thank you.